These are notes on basic stoichiometry. It's chapters 12.1 through 12.3 in your book. They have a lot of examples. They go through a lot of different types of stoichiometry. I'm going to give you a couple of examples, but if you want more examples or examples of a certain type of stoichiometry, I really recommend you look through your book. So stoichiometry basically relies on the mole conversions that you learned earlier this year when we did that whole unit on mole conversions. So you may want to go back and review some of those from the notes. You may want to go back and look at some of those worksheets we did. If that was something you were kind of glad was done with, you're going to need it again. So let's take a reaction between aluminum chloride and fluorine gas. This reaction will occur because fluorine is more reactive than chlorine. So we know it's a single displacement reaction where a nonmetal is replacing a nonmetal. If you have 3.2 grams of aluminum chloride, how many liters of chlorine gas will you produce? So we're going from grams of aluminum chloride, which is one of our reactants, to liters of chlorine gas, which is one of our products. So the first step in absolutely any stoichiometry question is to write a balanced equation. So pause the video, write your balanced equation, and then check your answer. So you should have had this balanced equation. 2AlCl3 aqueous plus 3F2 gas yields 2AlF3 aqueous plus 3Cl2 gas. So essentially 2 moles of aluminum chloride plus 3 moles of fluorine gas yields 2 moles of aluminum fluoride and 3 moles of chlorine gas. If you don't know where these numbers came from, you may want to go back either to balancing equations or forming compounds. So now we can figure out how we're going to get from grams of aluminum chloride to liters of chlorine gas. As you may remember from mole conversions, we can go from moles of something to liters if it's gas at STP, which we're assuming it is here. So that means kind of tracing back, we're going to need to get from chlorine gas liters to chlorine gas moles. We can do moles of chlorine gas and moles of aluminum chloride because we know here it's a 3 mole to 2 mole ratio. For every 2 moles of aluminum chloride, we have 3 moles of chlorine gas. So going backwards again, we've gone from liters of chlorine gas to moles of chlorine gas to moles of aluminum chloride, and then we can go from moles of aluminum chloride to grams of aluminum chloride. So that's thinking backwards. We're then going to write that equation forward. So we're going to start with our 3.2 grams of aluminum chloride. That's our given. And then we can convert. So go ahead again, pause the video, write the equation, see what you get. So this should have been your equation, our 3.2 grams of aluminum chloride. And then we're going, our grams of aluminum chloride cancel, and it's 1 mole of aluminum chloride is 1.33.341 grams. I calculated the molar mass based on the periodic table. Then I'm going to go my moles of aluminum chloride to moles of chlorine gas. So 2 moles of aluminum chloride, that's from here, gives me 3 moles of chlorine gas, that's there. Then I can convert my moles of chlorine gas to liters, so I know 22.4 liters is 1 mole of chlorine gas, because that's our volumetric conversion for gases at STP. And then I can, do 3.2 divided by 133.341 times 3 divided by 2 times 22.4, and that gives me 0.81 liters of chlorine gas. So if that's kind of hard, what I like to do is I always like to make a map. So this is essentially what I did. And I would do this at the beginning before I try to write my equation so that I then know what I want to write. So grams of aluminum chloride to moles of aluminum chloride to moles of chlorine gas to liters of chlorine gas. And if you look across the top, that's what we have. This follows our map perfectly. It goes grams of aluminum chloride to moles of aluminum chloride, to moles of chlorine gas, to liters. So across the top in all of your numerators should be the path you're taking to get from what you start with to what your answer is. So again, this is something I would write ahead of time, and then I would make my equation if you're having trouble conceptualizing this equation in your head. So like I said, in your book there are lots of examples of, how many grams of chlorine gas would that be? How many grams of aluminum chloride do I start with if I want to get 13 grams of aluminum fluoride? Lots and lots of examples in your book, and we're obviously going to do a lot of examples in class. If you want your book in class on Thursday for all those examples, make sure you bring it. I do want to talk about calculating limiting reactant, or you'll also hear it as reagent. There's two ways to do this, and I'm going to show you both. You only need to really know one, so do the one that makes more sense to you. Sometimes it makes more sense to do one than the other, but both will work no matter what. So the limiting reactant, as we've talked about, is the reactant that limits the amount of product you can make. Or, as a couple of people said in class, it's the reactant that you run out of first. The other reactant, or the other reactants, if there's more than two, are called the excess reactants. You have excess. Excess means extra, more than enough. So the first way to calculate the limiting reactant is based on the amount of product you get. So let's take this problem. Same reaction between aluminum chloride and fluorine gas. If you have 3.2 grams of aluminum chloride and 4.5 grams of fluorine gas, what is your limiting reactant? So again, the first thing you need to do is write a balanced equation. So same balanced equation. Then what you need to do is essentially calculate, if I have 3.2 grams of aluminum chloride, how much chlorine gas is that going to give me? How many moles? I could easily pick aluminum fluoride. In this case, I'm going to pick chlorine gas. It's completely arbitrary. That means it doesn't matter which product you choose. I chose chlorine gas. So I calculate how many moles of aluminum chloride, or how many moles of chlorine gas would I get with 3.2 grams of aluminum chloride. Then I calculate how many moles of chlorine gas will I get with 4.5 grams of fluorine. So essentially I'm saying how many moles of chlorine will I get with this much aluminum chloride, and how many moles of chlorine will I get with this much fluorine gas. So go ahead and calculate those. Pause the video, calculate them, then check your work. So this is what you should have gotten for the aluminum chloride. If I have 3.2 grams of aluminum chloride, 1 mole of aluminum chloride is 133.341 grams. So that's going to give me moles of aluminum chloride. And then 3 moles of chlorine gas over 2 moles of aluminum chloride. So that's going to leave me with 0.036 moles of chlorine gas. That's how much chlorine gas I could make with that much aluminum chloride. So now I want to see, what about the fluorine gas? How many moles could I get from my 4.5 grams of fluorine gas? And I want to use the same product. So I said it's arbitrary which product you choose, and that's true. But in order to properly compare, you have to use the same product in both calculations. So you can think of that as almost a control variable. So here are my moles of chlorine gas. Sorry about that brief interruption. So you've got the moles of chlorine gas, and so to get there in this case, you are going from your 4.5 grams of fluorine gas. Fluorine gas is 37.996 grams per mole. There are 3 moles of chlorine gas to 3 moles of fluorine gas, which is a 1-to-1 ratio. So certainly you could write 1-to-1 here if you wanted. It's not going to change the result. I do want you to put this in. Some of you, especially the lazier among you, will say, well, can I just ignore that because it's 1-to-1, so it doesn't count? You can ignore it on your calculator, but I want you to put it in the actual equation simply so that you remember, because there are times when that is important. And I would hate for you, in this case, it was very important. In this case, not so much. So it's better to have it there and not need it than to need it and forget that you were supposed to put it in. At any rate, that then gives you 0.12 moles of chlorine gas. So looking at these two answers, which one would be your limiting reactant? Pause the video, make a decision. It would be your chlorine gas, right? You can form less chlorine gas with, I'm sorry, it wouldn't be your chlorine gas. It would be your aluminum chloride is your limiting reactant. You can form less chlorine gas from this much aluminum chloride than you could from this much fluorine gas. So aluminum chloride is your limiting reactant, because you're going to, after you formed 0.036 moles of chlorine gas, you're going to run out of aluminum chloride. You will still have grams of fluorine gas left over. The second way to calculate limiting reactant is based on the molar ratio. And if you have the number of moles and you understand how to do this, this is where you can save yourself a step over calculating based on the product. If you don't have the number of moles, it sort of is whatever you're more comfortable doing. So exact same problem as before, 3.2 grams of aluminum chloride, 4.5 grams of fluorine gas. What is your limiting reactant? Exact same equation as before. In this case, though, we're going to calculate the number of moles of 3.2 grams of aluminum chloride and the number of moles of 4.5 grams of fluorine gas. So that's calculated like this. We would end up with 0.024 moles of aluminum chloride and 0.12 moles of fluorine gas. Now we're not done. In this example, as it turns out, the one with more moles ended up being the one in excess, and the one with less moles ended up being the limiting reactant. But that's not always true, because of the fact that this is not a one-to-one ratio. And so don't assume, well, I can just stop here. That happened to work out in this case because I chose arbitrary numbers. If I had wanted to make sure that the one with more moles was the limiting reactant, I could have spent some more time calculating amounts. So now what I do is I choose one of these molar amounts. And again, it doesn't matter which one, it's arbitrary. And so I'm going to take my aluminum chloride, and I'm going to write an equation like this. My 0.024 moles of aluminum chloride, and then I'm going to calculate how many moles of fluorine gas I would need for that many moles. So I say it's 3 moles of fluorine gas to 2 moles of aluminum chloride. So my moles of aluminum chloride cancel. I'm left with moles of fluorine gas. And I end up with 0.036 moles of fluorine gas. That means in order to completely react 0.024 moles of aluminum chloride, I would need 0.036 moles of fluorine gas. I have 0.12 moles, way more than I need. Again, showing me that aluminum chloride is my limiting reactant. Please add any questions or comments to YouTube or ask them Thursday in class. Have a good night.